Section 5.2 is about the integers and order of operations. As we mentioned in the last video, the natural numbers are the set of numbers that begin with the number 1, and these are all the counting numbers. So 1, 2, 3, 4, etc. The little 3 dots or the ellipse, meaning continue that pattern forever. So these are all the positive counting numbers, are natural numbers. Whole numbers are going to be all of the natural numbers and also the number 0. So this is the set. Remember, in mathematics, we denote a set by using those curvy brackets. And the set of numbers that start with 0, 1, 2, 3, 4, etc. So all the natural numbers are also whole numbers, and then the number 0 is also considered a whole number. You can probably guess what's coming next, continuing with this pattern. The integers, which is the title of this section, are going to be all the whole numbers as well as the negative non-decimal numbers. So I'm going to write ... -4, -3, -2, -1, 0, 1, 2, 3, 4, ... So including all the negative numbers, we still don't see any decimal numbers other than just 0.0. So for example, 3.4 is not an integer. However, 3.0 is an integer, and -3 is an integer. So whenever we hear negative numbers, 0, positive numbers, as long as they're non-decimals, it's just 0.0 in the decimal part, they are integers. So we're going to be comparing some integers in a minute here in example 1. Before we do that, keep in mind inequalities, the prefix in means not equal to. So if something is not equal to another number, it must be either less than or greater than the other number when you're comparing numbers. And less than, the symbol for less than is the arrow pointing to the left, whereas greater than is when that arrow, that inequality, points to the right. And as we're filling in the blanks here in a minute, just keep in mind, if it's been a while since you've worked with inequalities, we always want to open the inequality symbol towards the larger number. So it should always open towards the larger, and I'll just use hashtag to abbreviate number. So example 1 says to insert either the less than symbol or the greater than symbol in the underlined area between the integers. So we're going to be comparing integers, stating which integer is bigger than the other one, to make each statement true. So a couple different ways you can get the right answer here. You could do it like my math lab is going to suggest, which is to keep in mind that the larger numbers always come to the right on a number line. So for example, if I'm drawing a number line here in blue, so -3, I'll just throw just a few numbers on my number line here. But you can see the further right you go on the number line, the bigger the number is. Whereas, obviously, if you go to the left on a number line, you're going to encounter the smaller numbers. So if I'm using that, I can see that -2 is bigger than -3 because -2 is to the right of -3 on a number line. So that's the first way you could get the right answer for all these parts of example 1. Whatever number is further to the right on a number line, that's your larger number. You want to open your inequality symbol towards that number. Option 2, and the way that I do this type of a question, is I think of money. So a positive number represents money I have, so money that's in my bank account. 0 means I have no money, but I don't have any debt either. And a negative number is debt, it's money I owe. And I always want to open my inequality symbol towards the scenario I would prefer if I'm forced between the two options. So what do I mean by that? Okay, so A says 6, and then we got to fill in the blank -7. So we're comparing 6 to -7. So 6, it's a positive 6. So would I rather, if I had to choose, would I rather have $6? Or -7 means would I rather owe $7? Well, obviously I'd rather have money than owe money. So positive 6 is going to be bigger than -7. So I'm going to draw. In this case, it's a greater than symbol, but the point is I'm opening towards 6. B, they want us to compare -8 to -1. So -8 means I owe $8 versus -1 means I owe $1. If I had to choose between those two scenarios, I would rather owe $1 than owe $8. So -1, the scenario you would prefer in real life, is the larger number. So -1 is bigger than -8. So I'm going to open, again, open always towards the larger number. So I'm going to open towards -1. I'd read this out loud as -8 is less than -1. Or draw the number line, and you would see that -1 is to the right of -8 on a number line. Therefore, -1 is larger. C, now they want us to compare -25 to -2. So in real life, if I had to choose, would I rather owe $25, be in debt $25, or be in debt $2? Well, obviously I'd rather, if I had to choose, be in debt $2. So -2 must be the larger number. So I'm going to open towards -2. So -25 is less than -2 is how I would read that out loud. And finally, D, -14 and 0. So would I rather negative, again, meaning I owe money, would I rather owe $14? Or 0 means I don't owe any money, but I don't have any money either. If I had to choose, I would rather not be in debt. I'd rather owe nothing. So 0 is larger than -14. So I end up with -14 is less than 0 as the final answer. Or think of a number line. 0 would be to the right of -14 on a number line. So 0 is the larger number. The absolute value in mathematics is represented by two vertical lines or bars. And when we see a number inside of those bars, what happens when we apply the absolute value bars to the number is it makes any negative sign go away. So if I have just like a negative number, then the positive number comes out of it. So absolute value makes a number at the very least non-negative. So I either get out 0 or a positive answer every time. I do not get a negative answer out. And the reason why is that absolute value represents distance. So when you see the two bars around some number, we'll call it A in our math definition. The absolute value of A is really the distance from the number 0 to A on a number line. So in mathematics, it's the distance from the number 0 to whatever that number is inside the absolute value bars on a number line. They do use absolute value to represent distance in physics as well. It also will give us speed in physics, so a little bit of a different distance than in mathematics, where it's the distance from the number 0 on a number line. So example 2, find the absolute value, and we got A through E. Let's start with A. So A says to find, I see the absolute value bars, the two bars around -3. So find the absolute value of -3 and then explain what this means. So the absolute value of -3, well, we said a negative number inside the absolute value bars. What happens when we apply the bars is we say goodbye to the negative sign, so it becomes +3. So, final answer, the absolute value of -3 is +3. Now it wants us to explain what that means. What that means is we found a measurement. We found the distance from 0 on the number line. So, whatever was inside the absolute value bars, in this case -3, is, and our answer is the number of units away from 0. So our answer was +3, so -3 is 3 units from the number 0 on a number line. I'll just abbreviate number with a hashtag. So -3 is 3 units from the number 0 on a number line. Or even if I just think about a number line, so I'll draw a little number line in my blue pen up here. The number that was inside the absolute value bars was -3, which is right here. X marks the spot. And our answer was +3, and what that answer of +3 represents is that -3 is 1, 2, 3 hops away, or 3 units away from 0 on a number line. Let's try another one, part B, same directions, but now it wants us to find the absolute value of +5 and explain what this means. So the absolute value of 5, well, there isn't any negative sign to worry about, so it just comes back out as 5 again. So the only thing absolute value does is get rid of any kind of negative sign, which there wasn't any in this particular question. Explain what this means. It means that, in this case, 5 was inside the absolute value bars. So +5 is 5 units from 0 on a number line. So any number, any solo number inside absolute value bars, the only thing that happens is negative sign goes away. All right, so then they're going to try to amp it up a little bit more in the My Math Lab homework. Looking at C, the absolute value of 0. Keep in mind, 0 has no sign to it whatsoever. So there is no negative sign for the absolute value bars to take away. So the absolute value of 0 is just 0. And if you think about the definition of absolute value, that makes sense because 0 is 0 units from itself on a number line. Okay, amping it up a little bit more, I take a look at D. D, we have a negative sign in front of the absolute value bar. So that's going to change up our answer a little bit. We have negative absolute value of -1. So I would still apply and take care of the absolute value bars first. However, keep in mind, we only can apply absolute value to what's inside the bars, not outside the bars. So what happens is, when we do the absolute value of the -1, sure, that still becomes +1, but we still have a negative sign in front to bring down. So we end up with a negative answer. We end up with -1. So whenever you have a negative sign in front of or outside of those absolute value bars, that is when you can end up with a negative final answer. So again, we did the absolute value, the number inside absolute value we took care of first, and we got a +1 out, but then we brought down the negative that was in front of the bars, and that's how it became -1. It's like saying, do -1 times the absolute value of -1. So that was -1 times 1, which is -1 again. Same idea for E, negative absolute value of 15. So we do the absolute value of 15 first, which is just 15 again, but because you have the negative in front of the bars, you end up with -15 as the final answer. So negative final answer when negative sign is outside in front of the absolute value bars. You will also see in your My Math Lab assignments some good old order of operations questions. And honestly, it's up to you how you want to get the right answer. You can do it longhand. Or if you want to use the graphing calculator, that works too. What's awesome about the graphing calculator is that it is programmed to do order of operations. Yay! However, only the graphing calculator will do order of operations. So the default calculator, for example, that comes on your phone is not going to work. It has to specifically be a graphing calculator or a graphing calculator app on your phone that you're using to get the correct answer. So if it's been a while since you've done order of operations, let me refresh your memory. You might remember the memory tricks, which were PEMDAS, or please excuse my dear Aunt Sally. So let's talk about what all those letters stand for. So starting with the P in PEMDAS, the P stands for parentheses. And specifically what we mean by that is you'll always, in any type of math you're studying, do inside parentheses first. Now keep in mind, parentheses means any grouping symbol. So it could be open parentheses, but it could also be those solid brackets. So solid brackets are a type of parentheses. So if you see any type of grouping symbol, regular open parentheses or solid brackets, you will always do inside those parentheses from left to right first. When I say from left to right, I mean if you have multiple sets of parentheses, you would do the parentheses on the far left first. You could also see parentheses inside parentheses. So maybe you have both solid brackets and the open parentheses. When this happens, you will always do the inner parentheses first. So you'd work your way from the inside out whenever that happens. So if you have parentheses within parentheses, again, do the innermost parentheses first, then move on to the outer parentheses. Once you get it down to one number inside parentheses, then you're done with step 1. So now step 2, the E in PEMDAS stands for exponents. So any exponents you see from left to right, you would take care of those next. Here is one of the most common mistakes in the order of operations. MD, notice how I wrote it with a slash in between them? It's so easy to forget. M and D do stand for multiplication and division, But what's so easy to forget is multiplication and division, you do whatever comes first from left to right. So multiplication / division from left to right. You read a math problem just like you read a book, from left to right. But whatever comes first, if you see division from left to right before multiplication, you would actually do the division first. And I'll explain it better when we see some examples here in a couple minutes. But I see so many times on social media, like Facebook, where people say, oh, this is such a hard math question. Can you get the right answer? And the reason why so many people get the wrong answer is they remember PEMDAS from grade school, and they just automatically assume that because in the memory trick, M comes before D, they assume, oh, I'm always going to multiply before I divide, and that's not the case. So that's why this memory trick is not the best memory trick, because multiplication and division are actually on equal footing. Whatever symbol you see first from left to right, that's what you do first. And the same thing for addition and subtraction. You'll notice I also drew a slash in between A and S. A for addition, S for subtraction. So step 4, reading your math question from left to right. Addition and subtraction. Actually, let me see if I can fit this in. Way over here. Let me try to write a little bit smaller. I want to make sure I leave some room here for example 3 in a second. With my big old handwriting, I'm already running out of room. Here we go. Addition and subtraction. I'll just put slash like I did with multiplication and division. Addition and subtraction, which is also from left to right. Whichever symbol you see first, you do that first. That's what takes precedence from left to right. Okay, so to show you what I mean with these steps, example 3, there's an A and a B on this slide, and then there are a couple more parts to this example on the next slide. So we get lots of examples for good practice going. But let's see here. So A says 6 squared minus 24 divided by 2 squared times 3 plus 1. Please be aware in the homework, sometimes with times they'll use the traditional times symbol like this. Sometimes they'll use parentheses. Sometimes they'll use a closed dot. But so many different ways that it all means multiplication. So just be on the lookout for that. Okay, so here we go through the steps. We said step 1, parentheses. So we do not see any parentheses as I skim part A, example A from left to right. So step 1 is already done. No parentheses to worry about. So I'm on to step 2, which is exponents. I do have a couple exponents. So going from left to right, skimming that question again, the first exponent I encounter is 6 squared. So when I do 6 squared, or 6 raised to the second power, 6 times 6 would of course be 36. Bring the rest down, so bring down the minus 24. Bring down the divided by, and as you're bringing the rest down, I'm still on the exponent step, so the next exponent I see is 2 squared, so 2 raised to the second power, or 2 times itself is of course 4, and then bring the rest down, so bring down the times 3, and bring down the plus 1. So all I've done here are the 2 exponents in blue pen. I did the 6 squared and then I did the 2 squared. Everything else I haven't touched yet. I brought it down as is. So exponents done. All right, here we go with step 3. So step 3, multiplication and division. Whatever we see first, skimming from left to right, that's what we do first. So when I skim this from left to right, this would be a great Facebook math question, because this would be a question that a lot of people would get wrong. Because as I go from left to right, division comes before multiplication. So whatever's further to the left, that's what we do first with multiplication and division. That's what takes precedence. So here, division is further to the left than multiplication. So I got to divide. So bring down everything else. I'm going to bring down the 36, and I'm going to bring down this negative sign. But I am going to do 24 divided by 4, which equals 6. And bring the rest down, times 3 plus the 1. So I just divided 24 divided by 4. I brought everything else down, including the negative sign that was in front of the 24. Or you could think of it like negative 24 divided by 4 is negative 6. I am still on step 3. I am still on the multiplication and division step. Now I can multiply 6 times the 3. So as usual, I'm running out of room with my big old handwriting here, but I'm going to bring over the 36. I'm going to bring over this minus sign still, and now I'm just doing 6 times 3, which is 18, and bring over the plus 1. So see how I chip away at it piece by piece, and I just keep skimming left to right for each step. So now there's no multiplication or division left, so step 3 is done. Step 4, addition and subtraction. And again, whatever's further to the left takes precedence. So as I go from left to right, I see that subtraction comes before addition, so I'm going to subtract before I add in this question. So I do 36 minus the 18, which is 18 again. Then I bring down the plus 1. And now I'm still on step 4, but now I can finally add 18 plus the 1, which is 19. So the final answer, and the only thing I would type in the answer box, is 19. 19. But you can see, especially if it's been a while, since you've done the order of operations longhand, how steps 3 and 4 are trickier, especially with our memory trick. PEMDAS, please excuse my dear Aunt Sally. We got to be really careful with MD and AS. Let's go ahead and take a look at what that looks like if you choose to use the graphing calculator or graphing calculator app on your phone. So with the graphing calculator, this type of a question is super easy. We just simply punch it in and hit enter for equals. I would type in so I had, this is part A again, 6 squared, so you could either hit the x squared button, or this is the up arrow or the caret for any kind of exponent. So either way, I'm just going to use the up arrow, type in the 2. If you use this way, see how the cursor is still floating in the air as an exponent? So I have to hit the right arrow key right here, and then it brings my cursor back down to ground level. Minus, and then we had 24 divided by 2, and now 2 is raised to the second power. Again, right arrow key, times 3 plus 1, enter, and bam, very easy. I still get the same exact final answer of 19. Please be aware, fraction bar means division. So when you hit the division button, it is going to kind of look like a fraction there. And that's how you could get the answer to any order of operations questions you'll encounter in this course. on the graphing calculator. It is good to know how to do these longhand though, especially if you have kids or you plan on having kids one day. I've had a lot of former students that have contacted me to assist them with their kids' mathematics homework, and there seems to be a lot of order of operations questions going on in grade school and middle school where they don't allow them to use the calculator. So it is something that's good to know and kind of keep in the back of your mind, even if you do choose to use the graphing calculator for these types of questions in this course. All right, let's try B. So looking at part B, again, order of operations. So we're going to start with step 1, which is parentheses. Now, even though I literally see 3 sets of parentheses in this question, what I mean by parentheses is there something besides just one number inside parentheses? If so, we take care of that first. Is there an actual computation? Is there adding, subtracting, multiplying, dividing, exponent? Is there something besides just one number inside parentheses? Because if there's just one number inside parentheses, then we don't have to worry about it. So like, what do I mean by that? Well, if I look at this question from left to right, -6 is by itself in parentheses. There's no computation to be done there. However, as I go from left to right, there is parentheses inside these parentheses in the middle here, 5 minus 7, that can go down to -2. So, is there something to be done inside parentheses? That's what the parentheses step really means. Not just, hey, do you see some parentheses? So from left to right, we said -6 is already down to one number, so we don't have to worry about that, squared. So I just bring that down. I bring down the minus sign. However, right here, 5 minus 7 equals -2. So that is the parentheses step. Bring down the rest, so that's still going to be squared. Bring down times. -3 is already by itself in those parentheses. So only the 5 minus 7 really is what we have to take care of here with the parentheses step, where we had an actual computation, more than one number inside parentheses. So step 1, done. All right, step 2, exponents. So we do have a couple exponents. So again, looking left to right, -6 squared. And be careful because they'll try to trip you up a little bit on the homework. We got to make sure, is the negative sign inside the parentheses or outside the parentheses? Because when it's inside the parentheses like we have here, we're going to square the negative sign as well. In other words, the exponent applies to the negative sign when the negative sign is in the parentheses. So this is -6 squared, which means -6 times another -6, which is positive 36. So -6 times -6 for positive 36. We're still on the exponent step. Just simply bring down the minus sign that's kind of outside all these parentheses. We're not going to mess with it in this step. But I do see another exponent right here. I see a -2 squared. So that's -2 times -2 for positive 4. So I'll put x's over what I've taken care of, exponent-wise. So even though -2 squared is positive 4, notice I ended up with a -4 because I brought down that negative sign in blue in the middle. So the negative that was with the 2 in parentheses went away, but the negative outside the parentheses remains. And I haven't touched yet the times -3 that's hanging off the end there, so I'm going to bring that down as well. So all the exponents are done. Everything else I just brought down. Step 3, now we do any multiplication or division from left to right. I don't see any division, but I do have multiplication. So I do see 4 times negative 3. So I'm going to bring over the 36 and I'm going to bring over the minus that's still sitting there in the middle. But when I do the 4 times negative 3, that gives me negative 12. Now I have a double negative. So I've done with step 3, multiplication and division step. I'm on the last step, step 4, addition and subtraction. So minus and negative. Well, you could think of that as subtraction, or actually you could even think of it as multiplication. Negative times a negative is going to make a positive. So negative times negative, or double negative, does make positive for addition. So this becomes 36 plus 12 for 48 as the final answer. 48. Or type it in the graphing calculator just like you see it. Either way, you should be getting 48. Taking a look at C, this is the same directions. We want to simplify by using the order of operations. Keep in mind, step 1, we would do anything that's inside parentheses first to get it down to one number in parentheses. As I look at C, the only set of parentheses I see, it's already down to one number, so that is done. So no parenthesis step to really worry about with C. So then the second step was exponents. I do see a few exponents. So left to right, be careful here. The first exponent I see is 10 squared. Notice there's no parentheses around negative 10. So what that means is you are not squaring the negative sign. This is just positive 10 squared. If they wanted you to square the negative sign as well, it would have parentheses around negative 10. So when I do 10 squared, or 10 times 10, I get positive 100. Since we haven't touched that negative sign in front, just simply bring it down. So then it becomes negative 100. So again, I just did 10 squared for 100, and I brought down the negative sign that was in front. I'm going to bring down the minus 100 that comes after it, and the divided by sign. But I'm still on the exponent step. I see 5 squared, which would be 25, and bring down the rest. That dot, by the way, means times. If it bothers you, you can always change it to a traditional looking X for times. So that's what I'm going to do, times 2. Actually, let's go ahead and put this in blue. Times 2 minus, there we go, the negative 3. All right, so I left in just the red pen the 2 exponents that we did in step 2. Step 3, now we do multiplication and division, whatever comes first from left to right. As I look at this question from left to right, I actually see division further to the left than multiplication. So that means division will take precedence here. So when I do 100 divided by the 25, I get 4. Bring down the rest. So let's bring down the minus 100. And let's also bring down, there's a minus sign in front of the division there as well to bring down. Bring down the times 2 and the minus negative 3. I'm still on the multiplication and division step as I go from left to right. Now I can do multiplication is next, 4 times 2. So bring down the negative 100 in front. Bring down this minus sign is still sitting there. But when I do the 4 times 2, I obviously get 8. After you take care of that, you can actually even think of the double negative in front of the 3 as multiplication as well. So I have negative times negative, which makes positive, and bring down the 3. So this is like saying negative 1 times negative 3, in other words, with this double negative. So I just made the double negative into a positive. So multiplication and division is now all done. So I'm on step 4, the last step, which is addition and subtraction. As I go from left to right, I actually see subtraction further to the left than addition. So subtraction is going to take precedence in this example. Negative 100 minus 8 is negative 108. Bring down the plus 3 is still hanging off the end. Now I'm going to do negative 108 plus 3, which gives me a final answer of negative 105. You could also type it, of course, into the graphing calculator. Same answer, negative 105. And finally, D. We got 24 divided by solid bracket there, 3 squared divided by parentheses 8 minus 5, close parentheses, close bracket minus negative 6. So we're going to do inside parentheses first. And I briefly mentioned earlier that when you have parentheses inside parentheses, you do the inner parentheses first. So I'm going to do the 8 minus 5 for 3 first and just bring down the rest. So I haven't touched the 24 divided by bracket 3 squared. Bring down the division symbol right there. The other bracket, everything else. So do the inner parentheses first. Done. Okay, I'm still on the parentheses step. Now, remember, brackets are a type of parenthesis. So now I'm looking here. I see an exponent and a division symbol. So I'm going to go through the regular order of operations. You would do an exponent before you would ever divide. So bring down the 24 and the divided by. But I'm going to do the 3 squared for 9. Bring down the divided by 3 and the rest. I am still on the parentheses step. I'm still on step 1. Now that I've done the exponent in the brackets, now I can finally finish off these brackets by doing 9 divided by 3. And just bring down the rest. So when I do 9 divided by 3, there we go, we get 3. Now that I got it down to one number in the parentheses, I am done with those parentheses. Yay! So now step 2, any exponents that are left. No exponents are left, so step 2 is also done. Check. Step 3, multiplication and division. So as I go from left to right, I see division first. So 24 divided by 3 would be 8. Then I see multiplication over here. Negative times negative is positive. So plus 6. And now I'm on the last step. I see addition. 8 plus 6 for 14. So 14 is the final answer for D. So just be careful when you're doing these order of operation questions. I'm noticing that the 4 I chose for this video, division happened to come before multiplication, but that's not always the case. So again, the rule is when you hit step 3 with multiplication and division, whichever one is further to the left in that math problem, that's what you do first. So it just happened to be the case in the video here that division was further to the left, but you could of course have multiplication come first if that's further to the left, and then you would tackle that first before division. Same rule applies for addition and subtraction. Whichever one is further to the left takes precedence over the other.